Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 21 Trigonometric Identities. We will be discussing questions from exercise 21E. In our previous classes, we have discussed trigonometric ratios and trigonometric identities, which we will be using to solve questions from exercise 21E today. Ready? Let's start. Here we have today's first problem, question 1 of exercise 21E. Prove the following identities. The first question is 1 by cos A plus sin A plus 1 by cos A minus sin A is equal to 2 cos A divided by 2 cos square A minus 1. Here, take the left hand side. What is there in the left hand side? LHS we have 1 by cos A plus sin A plus 1 by cos A minus sin A. Okay, from here we will be starting. We should reach RHS. For that, the first step is consider the denominators. Take the LCM of the denominators. Cos A plus sin A, cos A minus sin A. Therefore, the denominator will be getting cos A plus sin A into cos A minus sin A as the LCM of denominators. Okay. Now, here we have cos A plus sin A, which means we have to multiply 1 and cos A minus sin A. 1 into cos A minus sin A is cos A minus sin A. Next, here we have cos A minus sin A. Therefore, 1 into cos A plus sin A plus cos A plus sin A. Okay, this is minus sin A and here we have plus sin A. So, they can be cancelled. Remaining we have cos A plus cos A. What is cos A plus cos A? Cos A plus cos A we get 2 cos A. So numerator we got 2 cos A, which is there in the RHS. Now the denominator. Cos A plus sin A into cos A minus sin A. This is of the form A plus B into A minus B. What is A plus B into A minus B? We have studied algebraic formulas. A plus B into I minus B is equal to A square minus B square. So here in place of A we have cos A. In place of B it is sin A. Therefore cos A plus sin A into cos A minus sin A will be equal to cos square A minus sin square A. Okay. Denominator, what do we have in the RHS? It is 2 cos square A minus 1. We don't need sin square A. Here we have sin square A. So that we need to change this sin square A. What can be done? We have studied an identity. Remember? Sin square A plus cos square A is equal to 1. This is our identity. What should be done now? To remove sin square A. What is sin square A from this? We have sin square A is equal to 1 minus cos square A. Okay. So, we can substitute in place of sin square A 1 minus cos square A. On substituting, what do we get? We get LHS part equal to 2 cos A divided by cos square A minus 1 minus cos square A. Okay. That is equal to 2 cos A divided by cos square A. Removing the brackets and multiplying with this negative sign, we get minus 1, minus of minus plus cos square A. That is equal to 2 cos A. Numerator is the same. Cos square A plus cos square A, we get 2 cos square A minus 1. This is what RHS is. 2 cos A divided by 2 cos square A minus 1. So, we got the RHS. From left hand side, we started and reached the RHS. So, this is the required proof. Next, second problem, sub question 11 of question 1, exercise 21E. Here we have 1 plus sec A minus tan A whole square divided by cosec A into sec A minus tan A is equal to 2 tan A. Okay. So, LHS, take the left hand side part, equal to 1 plus sec A minus tan A whole square divided by cosec A into sec A minus tan A. Okay. We have sec, tan, cosec. Now this 1 can be changed. We have 1 plus tan square A is equal to sec square A, which means 1 is equal to sec square A minus tan square A. This will be helping us to solve and bring 2 tan A. So in place of 1, using this identity, 1 plus tan square A is equal to sec square A, we are going to substitute 1 is equal to sec square A minus tan square A. LHS becomes sec square A minus tan square A plus sec A minus tan A whole square divided by cosec A into sec A minus tan A. Now here, this part, you have A square minus B square form, sec square A minus tan square A, which can be written as sec A minus tan A into sec A plus tan A. Okay, A plus B into A minus B is equal to A square minus B square. Therefore, sec square A minus tan square A will be equal to sec A minus tan A into sec A plus tan A. Okay, now the next part, here we have sec A minus tan A whole square. Denominator is cosec A into sec A minus tan A. Okay. Now what is common? When you consider these two terms, sec A minus tan A is common in both these. So it can be taken out, sec A minus tan A. What is remaining? Here we have sec A plus tan A, sec A plus tan A. What about this part? Here sec A minus tan A. One sec A minus tan A is taken out. Remaining again we have sec A minus tan A plus sec A minus tan A. Now what is the denominator? Denominator we have cosec A into sec A minus tan A. Sec A minus tan A. Okay. Sec A minus tan A can be cancelled. Numerator part. Here we have sec A plus tan A, sec A minus tan A. Plus tan A minus tan A can be cancelled. Then we have 2 sec A in the numerator. Denominator is cosec A. Okay. 2 sec A can be written as 2 into 1 by cos A. Sec is the reciprocal of cos. Divided by, what is cosec A? Cosec A is 1 by sin A. 1 by sin A. Okay. Now taking the reciprocal and multiplying, we get 2 by cos A into sin A divided by 1. That is equal to 2. Sin A by cos A is tan A. So this is the required right hand side, 2 tan A. So we reached RHS. Clear? So here we have used the identity 1 plus tan square A is equal to sec square A, from which 1 is equal to sec square A minus tan square A. Okay. So this is the required proof. Hence proved. Clear? Problem number 3, sub-question 14, question 1 of exercise 21E. 1 minus 2 sin square A whole square divided by cos raised to 4A minus sin raised to 4A is equal to 2 cos square A minus 1. Okay. Here in the denominator we can see, when you take the left hand side, we have 1 minus 2 sin square A whole square divided by cos raised to 4A minus sin raised to 4A. Okay. When cos to the power of 4 or sin to the power of 4 comes, what we do? We write it as cos square A whole square minus sin square A whole square. Numerator is 1 minus 2 sin square A whole square. This is equal to 1 minus 2 sine square A whole square divided by, this is now of the form A square minus B square. In place of A we have cos square A. In place of B, sine square A. And the form is A square minus B square, which is equal to A plus B into A minus B. Okay. So here we are going to change the denominator to cos square A plus sine square A into cos square A minus sine square A. Okay. That is equal to 1 minus 2 sine square A whole square divided by, what is cos square A plus sine square A? Cos square A plus sine square A is equal to 1. Denominator remains cos square A minus sine square A. Because this part is equal to 1. We have used identity cos square A plus sine square A is equal to 1. Okay. Now what to do? In the numerator, we have 1 minus 2 sine square A. Denominator is cos square A minus sine square A. I am going to make a change in the denominator. This is equal to 1 minus 2 sine square A whole square divided by cos square A. What can we write cos square A in terms of sine square A? We have cos square A plus sine square A is equal to 1, which means cos square A will be equal to 1 minus sine square A. I am substituting 1 minus sine square A in place of cos square A. Then remaining we have minus sine square A. Okay. So this becomes equal to 1 minus 2 sine square A whole square divided by 1 minus sine square A minus sine square A is 1 minus 2 sine square A. Okay. So we have done this because once you get denominator 1 minus 2 sine square A, you can cancel this and the square can be cancelled because in the right hand side you have no denominator. So you don't need the denominator. To remove the denominator, we have made denominator similar to numerator. Okay, we have 1 minus 2 sine square A. Now what we need? We need in terms of cos. So the sign should be changed. Okay, sine square A will be equal to 1 minus cos square A. So to change sine square in terms of cos square, we are going to change this part. It becomes 1 minus 2, 1 minus cos square A. Okay, that is equal to 1 minus 2 into 1, 2. Then minus 2 into minus cos square A is plus 2 cos square A. Okay, that is equal to 2 cos square A. 1 minus 2 is minus 1. And this is the right hand side. So we got right hand side. So this is the proof. Understood? Next, sub question 16, question 1, exercise 21E. Cosec raised to 4a into 1 minus cos raised to 4a minus 2 cot square a is equal to 1. Let us take the left hand side. Left hand side is cosec raised to 4a 1 minus cos raised to 4a minus 2 cot square a. Okay. This can be written as cosec raised to 4a into 1 minus cos square a whole square. Okay. Here the power is 4, which can be written as cos square a whole square minus 2 cot square a. Now this part is in the form a square minus b square. In place of a we have 1. We know that square of 1 is 1. In place of b we have cos square a. A square minus b square can be changed to a plus b into a minus b. This becomes cosec raised to 4a into 1 minus cos square a into 1 plus cos square a. Okay. Minus the remaining part, that is 2 cot square a. This is equal to cosec raised to 4a. What is 1 minus cos square a? 1 minus cos square a is equal to sin square a into sin square a into 1 plus cos square a minus 2 cot square a. Here we have used the identity sin square a plus cos square a is equal to 1. Therefore, 1 minus cos square a is equal to sin square a. Okay, we know that the reciprocal of sin is cosec. So, this cosec raised to 4a can be 1 by sin raised to 4a. Okay, from that sin raised to 4a, this sin square can be cancelled. Then what will be remaining? You will be having sin square a in the denominator. 1 by sin square a will be equal to cosec raised to 2a. Cosec square a. Understood? How we got this? We have cosec raised to 4a sin square a. This becomes 1 by sin raised to 4a into sin square a. Sin square a, and this can be cancelled. It becomes sin square a in the denominator. 1 by sin square a is cosec square a. Okay. Cosec square a into 1 plus cos square a minus 2 cot square a, which is equal to, now removing this bracket and multiplying, we get cosec square a into 1 is cosec square a plus cosec square a cos square a minus 2 cot square a. Okay, that is equal to cosec square a plus cosec square a can be written as 1 by sin square a. So, here we get cos square a by sin square a minus 2 cot square a. That is equal to cosec square a. What is cos square a by sin square a? It is equal to cot square a. Cot square a. Cos by sin is cot. Therefore, cos square a by sin square a will be equal to cot square a minus 2 cot square a equal to cosec square a. Cot square a minus 2 cot square a is minus cot square a. What do we need? RHS we have 1. How to get 1 from this? We have studied an identity. 1 plus cot square a is equal to cosec square a. If 1 plus cot square a is equal to cosec square a, then we will be having 1 is equal to cosec square a minus cot square a. Okay, so we got 1, which is the RHS. So, this is the proof. Clear? Next, problem number 5, question 2 of exercise 21E. If sin A plus cos A is equal to P and Ck plus cosec A is equal to Q, then prove that Q into P square minus 1 is equal to 2P. Okay, so take the left hand side part. We have Q into P square minus 1. Now put the values. We have Q is equal to sec A plus cosec A and P is equal to sin A plus cos A. Okay, then the left hand side part becomes sec A plus cosec A into P square minus 1 sin A plus cos A whole square minus 1, which is equal to sec A plus cosec A into sin A plus cos A whole square can be written as sin square A plus 2 sin A cos A plus cos square A minus 1. We have used A plus B whole square is equal to A square plus 2AB plus B square. Okay. Now, we get sec A plus cosec A into sin square A plus cos square A is equal to 1. We know the identity. 1 plus 2 sin A cos A minus 1. This 1 and minus 1 can be cancelled. Then what is remaining? We get sec A plus cosec A into 2 sin A cos A. Sec A plus cosec A into 2 sin A cos A. Now removing the brackets, we get sec A into 2 sin A cos A plus cosec A into 2 sin A cos A. What is sec A? Sec A is 1 by cos A. So this becomes 2 sin A cos A divided by cos A, because sec A is 1 by cos A, plus 2 sin A cos A divided by cosec A is 1 by sin A divided by sin A. Now sin A can be cancelled. Similarly from here cos A can be cancelled. 2 sin A plus 2 cos A. 2 is common, taking out, we get sin A plus cos A, and that is equal to, what is sin A plus cos A? Sin A plus cos A is equal to P. 2P. So this is the required RHS. Okay. So we proved that Q into P square minus 1 is equal to 2P. Clear? Next problem number 6, question 3 of exercise 21E. If x is equal to a cos theta and y is equal to b cot theta, show that a square by x square minus b square by y square is equal to 1. Here again we are going to put values for x and y that is given in the question. Okay, similar to the question we have solved before. A square by x square minus b square by y square is equal to 1. We have x is equal to a cos theta and y is equal to b cot theta. Now put the values. A square divided by x square becomes a square cos square theta minus b square divided by y square becomes b square cot square theta. Okay. So this is the left hand side. Now this a square and a square can be cancelled. Similarly b square and b square can be cancelled. We get 1 by cos square theta minus 1 by cot square theta can be written as cos square theta by sin square theta. Next step, taking the reciprocal of this. This denominator part we are taking the reciprocal. Then we get 1 by cos square theta minus sin square theta by cos square theta. Okay. Now denominator is the same. When you take LCM, we get cos square theta in the denominator, cos square theta. And the numerator part, here we have 1 minus, here we have sin square theta. 1 minus sin square theta. What is 1 minus sin square theta? 1 minus sin square theta is cos square theta divided by cos square theta. Here we have used the identity sin square theta plus cos square theta equal to 1. Okay. Therefore, 1 minus sin square theta will be equal to cos square theta. Cos square theta in the numerator, cos square theta in the denominator, which can be cancelled, and we get 1, which is the right hand side. So we have proved a square by x square minus b square by y square is equal to 1, just by putting values for x and y that is given in the question. Very simple, right? Understood? Okay. Next, problem number 7, question 6 of exercise 21E. Here we have the first sub question. If 2 sin A minus 1 is equal to 0, show that sin 3A is equal to 3 sin A minus 4 sin cube A. So first we'll find what the value of A is. Given that 2 sin A minus 1 is equal to 0. Then we can write 2 sin A is equal to 1. Taking this negative 1 to the opposite side, it becomes positive 1. If 2 sin A is equal to 1, then we'll be having sin A is equal to 1 divided by 2. Where do we get 1 by 2 for sin? Sin A should be equal to sin of 30 degree. Okay, 1 by 2 value for sin is at 30 degree. Sin 30 degree is 1 by 2. If sin A is equal to sin 30 degree, then the value of A is 30 degree. Okay, we got A is equal to 30 degree. Now, take the left hand side part. Left hand side we have sin 3A. Sin 3A will be equal to sin of 3 into 30 degree, that is sin of 90 degree. What is sin 90 degree? Sin 90 degree is equal to 1. Left hand side we got 1. Now take the right hand side. RHS we have 3 sin A minus 4 sin cube A, that is equal to, put the value of A, 3 sin 30 degree minus 4 sin cube 30 degree. Okay. This is equal to 3 sin 30 degree. What is sin 30 degree? 1 by 2. So 3 into 1 by 2. Minus 4 sin cube 30 degree is sin 30 degree whole cube. Okay. Don't confuse. Sin cube 30 degree is sin 30 degree whole cube. This is 3 by 2 minus 4. What is sin 30 degree? Sin 30 degree is 1 by 2. 4 into 1 by 2 whole cube equal to 3 by 2 minus 4 into 1 by 2 cube. 2 cube is 8. Okay. 4 and 8 can be cancelled. We get 2 here. 3 by 2 minus 1 by 2. Denominator LCM we get 2. Numerator 3 minus 1. And that is again 2. 2 divided by 2 is equal to 1. So we got left hand side 1. Right hand side also is equal to 1. That is LHS is equal to RHS. Okay. So we have showed that sin 3A is equal to 3 sin A minus 4 sin cube A. Clear? Problem number 8, question 7 of exercise 21E. Evaluate sub-question 1. 2 tan 35 degree by cot 55 degree whole square plus cot 55 degree by tan 35 degree whole square minus 3 sec 40 degree by cosec 50 degree whole square. Okay, we have to find the value of this. Here we have 2 tan 35 degree by cot 55 degree whole square plus cot 55 degree by tan 35 degree whole square minus 3 sec 40 degree by cosec 50 degree whole square. Okay, this is equal to tan 35 degree. I am rewriting tan 35 degree as tan of 90 degree minus 55 degree divided by cot 55 degree whole square plus, here we have cot 55 degree which can be written as cot 90 degree minus 35 degree divided by tan 35 degree whole square minus 3 sec 40 degree. Sec 40 degree can be written as sec of 90 degree minus 50 degree divided by cosec 50 degree whole square. Okay, this is equal to 2. What is tan 90 minus theta? Tan 90 minus theta will be equal to cot theta. Similarly, cot 90 minus theta is equal to tan theta. Sec 90 minus theta will be cosec theta. We have studied all this. Sin 90 minus A is equal to cos A. Cos 90 minus A is equal to sin A. Tan 90 minus A is cot A and cot 90 minus A is tan A. Sec 90 minus A is cosec A and cosec 90 minus A is sec A. So, applying this, we get tan 90 minus 55 degree cot 55 degree, denominator also we have cot 55 degree whole square plus cot 90 minus 35 degree, that is tan 35 degree by tan 35 degree whole square minus 3 sec 90 minus 50 degree is cosec 50 degree by cosec 50 degree whole square. Cot 55 cancelled, tan 35 cancelled, cosec 50 cancelled. Okay, all this becomes equal to 1. So 2 into 1 plus 1 square, that is 1, minus 3 into 1 square, which is again 1. You will be getting 2 plus 1 minus 3, and that is 3 minus 3, which is equal to 0. So evaluating this expression, we get final answer 0. Clear? Next, problem number 9, question 9 of exercise 21E. If A and B are complementary angles, prove that. We are doing sub-question 3. Cosec square A plus cosec square B is equal to cosec square A into cosec square B. Okay, we'll start the proof. Here it is given that A and B are complementary angles, which means A plus B is equal to 90 degree. Since A and B are complementary angles. A plus B is equal to 90 degree. If A plus B is equal to 90 degree, then we'll be having B is equal to 90 degree minus A. Okay, here take the left hand side now. Left hand side is equal to cosec square A plus cosec square B. Okay, now this cosec square B I can rewrite as cosec square A plus cosec square 90 minus A. Okay, why? Because B is equal to 90 minus A. Cosec square 90 degree minus A. That is equal to cosec square A plus, what is cosec 90 minus A? Cosec 90 minus A is equal to sec A, which means cosec square 90 minus A will be equal to sec square A. Sec square A. Okay. Cosec square A can be written as 1 by sin square A plus sec square A becomes 1 by cos square A. Now take the denominators, take the LCM of this. LCM, sin square A and cos square A, we get sin square A into cos square A. What about numerator? Here we have sin square A, 1 into cos square A. Cos square A plus 1 into sin square A. Sin square A. So numerator we have sin square A plus cos square A. According to the identity, sin square A plus cos square A is equal to 1. So we get 1 by sin square A cos square A. This can be written as 1 by sin square A into 1 by cos square A, which is 1 by sin square A cosec square A into 1 by cos square A. What is 1 by cos square A? It is equal to sec square A. What we need? We need cosec square A into cosec square B. So the sec square A should change to cosec square B. What can be done? Angle A will be equal to 90 degree minus B. Okay. If A plus B is equal to 90 degree, B is equal to 90 degree minus A, and A will be equal to 90 degree minus B. I am putting it here. We get cosec square A into sec square 90 degree minus B. Okay, that is equal to cosec square A into sec square 90 degree minus B. What is it? Sec 90 minus B will be equal to cosec B. Then sec square 90 minus B will be equal to cosec square B. This is what our RHS is, cosec square A, cosec square B. Cosec square A into cosec square B. So we got the RHS. Okay, this is the required proof. Hence proved. Understood? So what are complementary angles? Sum of the angles will be equal to 90 degree. Just you need to remember this point. Next, problem 10, question 9, exercise 21E. Here we are taking the fourth sub-question. Sin A plus sin B divided by sin A minus sin B plus cos B minus cos A divided by cos B plus cos A is equal to 2 divided by 2 sin square A minus 1. Here again, A and B are complementary angles. Then we have A plus B is equal to 90 degrees. If A plus B is 90 degree, then A is 90 degree minus B and B is 90 degree minus A. Put these values, we get sin A plus sin B divided by sin A minus sin B. This is our LHS part, plus cos B can be written as cos of 90 minus A minus cos of 90 minus B. Cos A is 90 minus B divided by, here we have cos B. Cos B is 90 minus cos 90 minus A plus cos A. Cos 90 minus B, which is equal to sin A plus sin B divided by sin A minus sin B plus, what is cos 90 minus A? Cos 90 minus A will be equal to sin A. Sin A minus cos 90 minus B is sin B divided by cos 90 minus A again sin A plus cos 90 minus B sin B, which is equal to, here in the denominator we have sin A minus sin B, here it is sin A plus sin B. So taking LCM, sin A minus sin B into sin A plus sin B. What about the numerator? Here we have sin A minus sin B. Therefore, sin A plus sin B into sin A plus sin B. We get sin A plus sin B whole square plus, here we have sin A minus sin B. This is also sin A minus sin B, multiplying sin A minus sin B whole square. Okay. Now this is in the form A plus B whole square. This is A minus B whole square. A plus B into A minus B. Okay. A plus B whole square becomes A square plus 2AB plus B square. That is sin square A plus 2 sin A sin B plus sin square B plus A minus B whole square is sin square A minus 2 sin A sin B plus sin square B whole divided by A plus B into A minus B. This part becomes A square minus B square, that is sin square A minus sin square B. Okay. Now 2 sin A sin B minus 2 sin A sin B can be cancelled. Then we have sin square A plus sin square A, that is 2 sin square A. Then plus sin square B plus sin square B, 2 sin square B. 2 sin square B divided by sin square A minus sin square B. Now 2 is common, taking out 2. 2 into sin square A plus sin square B divided by sin square A minus sin square B. Okay. Now what can be done? Here I am going to replace B with 90 minus A. We get 2 into sin square A plus sin square 90 minus A divided by sin square A minus sin square 90 minus A, which is equal to 2 into sine square A. Sine of 90 minus A is cos A. Therefore, sine square 90 minus A is cos square A. Plus cos square A divided by sine square A minus sine square 90 minus A is cos square A. Cos square A. Sine square A plus cos square A, according to the identity, it becomes equal to 1. So, numerator we have 2 and the denominator is sine square A minus cos square A. What do we need? We need 2 sine square A minus 1, which means we have to replace this cos containing term with sine containing terms. How can you do this? Using the identity, we get cos square A will be equal to 1 minus sine square A. Putting this 2 divided by sine square A minus 1 minus sine square A. That is 2 divided by sine square A, removing the brackets and distributing the negative sign, minus 1 minus of minus plus sine square A, that is equal to 2 divided by sine square A plus sine square A, 2 sine square A minus 1. Okay, so this is the right hand side part, RHS. Okay, now we have proved that sin A plus sin B divided by sin A minus sin B plus cos B minus cos A divided by cos B plus cos A is equal to 2 divided by 2 sin square A minus 1. Understood? Let's move on to the next problem. Problem 11, question 12 of exercise 21E. Find A if 0 degree less than or equal to A less than or equal to 90 degree and given 5 conditions, that is, first one, 2 cos square A minus 1 is equal to 0. We have to find the value of A in this case. First one, 2 cos square A minus 1 is equal to 0. If 2 cos square A minus 1 is equal to 0, then we will be having 2 cos square A is equal to plus 1. Minus 1, when taken to the opposite side, it becomes plus 1. Then cos square A will be 1 divided by 2 and cos A will be equal to 1 by 2 root. Okay, that is square. Here we have cos square A and here we have 1 by 2. When you take the root of cos square A, you get cos A and the root of 1 by 2 is root of 1 by 2. That is cos A is equal to 1 by root 2. When do we get cos value 1 by root 2? It is at 45 degree. Then cos A is equal to cos 45 degree. Therefore, A value is 45 degree. Okay. So, for the first question, we got A is equal to 45 degree. Next, second one. Sin 3A minus 1 is equal to 0. Same procedures. What is sin 3A then? Sin 3A will be equal to minus 1 taken to the opposite side plus 1. Okay. We should get sin 3A plus 1. Where do we get sin value plus 1? It is at 90 degrees. So, sin 3A will be equal to sin 90 degree. The value of sin 90 degree is 1. Okay. Then what is 3A? 3A should be equal to 90 degree and A should be equal to 90 degree divided by 3. A is equal to 90 divided by 3, that is 30 degrees. Okay. A is equal to 30 degrees. Next, the third one. 4 sin square A minus 3 is equal to 0. Okay. Here 4 sin square A will be equal to 3. Minus 3 taken to the opposite side, we get plus 3. Then sin square A will be 3 divided by 4. What is sin A? Sin A should be equal to root of 3 by 4. And that is root 3 divided by 2. Root 4 is 2. When do we get sin value root 3 by 2? It is at 60 degrees. Therefore, sin A is sin 60 degree, which implies A is equal to 60 degrees. So, this is the third one. Now, the fourth one. Cos square A minus cos A is equal to 0. Cos square A minus cos A is equal to 0. What is common in both these terms? Cos A is common. So, I am taking cos A outside. Cos A into cos A minus 1 is equal to 0. Applying the 0 product rule. Either cos A should be equal to 0 or cos A minus 1 should be equal to 0. Cos A should be equal to 0. Then cos A equal to 0. Where do we get cos value equal to 0? It is at cos 90 degrees. So, cos A will be cos 90 degree and A value will be 90 degree. Okay. If cos A is equal to 0. Another condition is cos A minus 1 is equal to 0. Then cos A will be equal to plus 1. Where do we get plus 1 value in case of cos? It is at 0 degrees. Cos 0 is 1. Then A value will be equal to 0 degree. Okay. So, the two possible values of A are there in this case. Either A is equal to 0 degree or 90 degrees. Understood? So, this is the fourth one. Next, fifth one. 2 cos square A plus cos A minus 1 is equal to 0. To find the value of A, we have to write in place of cos A, 2 cos A minus cos A. Okay. This becomes 2 cos square A plus 2 cos A minus cos A minus 1 is equal to 0. Now, considering the first two terms, what is common? 2 cos A is common. Taking out 2 cos A, remaining we have cos A plus 1. Okay. From the third and the fourth terms, we will be taking minus 1 out. Then we have cos A plus 1. This will be equal to 0. Here cos A plus 1, here again cos A plus 1. Taking out cos A plus 1 into 2 cos A minus 1 is equal to 0. Okay. So, either this cos A plus 1 should be equal to 0 or 2 cos A minus 1 should be 0. If cos A plus 1 is equal to 0, then what is the value of A? Cos A should be equal to minus 1. So, here it is given that the values of the angle A should be between 0 and 90. It can be 0, 90 or any value between 0 and 90. Anywhere do we get this negative value? No, right? So, this value cannot be accepted. A cannot be more than 90 degrees or less than 0 degrees. So, here we are not getting any value such that it will be equal to minus 1. Next, 2 cos A minus 1 is equal to 0. Then 2 cos A will be 1 and cos A will be 1 by 2. Where do we get 1 by 2 for cos? Cos 60 degree is 1 by 2. Therefore, A value will be 60 degrees. Only one possible value because the other value cannot be accepted. We are not getting negative in between 0 degree to 90 degrees. Understood? Next, problem 12, question 15 of exercise 21E. Prove the identity sin theta plus cos theta into tan theta plus cot theta is equal to sec theta plus cosec theta. Take the left hand side. LHS, we have sin theta plus cos theta into tan theta plus cot theta. That is equal to sin theta plus cos theta into tan theta is sin theta by cos theta and cot theta. What is cot theta? Cot theta is cos theta by sin theta. Okay. This becomes equal to sin theta plus cos theta into, here denominator is cos theta, here denominator is sin theta. When you take LCM, we get sin theta cos theta. Cross multiplying sin theta into sin theta sin square theta, cos theta into cos theta is cos square theta plus cos square theta. Okay, what is sine square theta plus cos square theta? Sine square theta plus cos square theta according to the identity is equal to 1. Therefore, we are having sine theta plus cos theta divided by sine theta cos theta. And that is equal to sine theta divided by sine theta cos theta plus cos theta divided by sine theta cos theta. Okay, this sine theta and denominator sine theta can be cancelled. Similarly, this cos theta and cos theta can be cancelled. What is remaining? We are having 1 by cos theta plus 1 by sine theta. We have almost reached the RHS. Yes, here we have sec theta. What is sec theta? 1 by cos theta is sec theta plus 1 by sine theta is cosec theta. Okay, so this is our RHS. Understood? Next, problem 13. This is our last problem for today. Question 16 of exercise 21E. Evaluate without using trigonometric tables sine square 28 degree plus sine square 62 degree plus tan square 38 degree minus cot square 52 degrees plus 1 by 4 sec square 30 degree. Okay. We have to find the value sine square 28 degree plus sine square 62 degree plus tan square 38 degree minus cot square 52 degree plus 1 by 4 sec square 30 degree. That is equal to sine square 28 degrees. Sine square 28 degrees plus sine square 62 degree can be written as 90 minus 28 degree plus tan square 38 degree minus cot square 52 degree can be written as 90 degree minus 38 degree plus 1 by 4 sec square 30 degrees. Okay, that is equal to sine square 28 degree. What is sine square 90 minus 28 degree? Equal to cos square 28 degree plus tan square 38 degree minus cot square 90 minus 38 degree will be equal to tan square 38 degree plus 1 by 4 sec square 30 degree. What is sec 30 degree? We know cos 30 degree is equal to root 3 divided by 2. Then sec 30 will be equal to 2 by root 3. 2 by root 3 whole square. There is a square. Okay. Sine square 28 degree plus cos square 28 degree. Sine square theta plus cos square theta is equal to 1. So, this part becomes equal to 1. Tan square 38 degree and minus tan square 38 degree can be cancelled. This part becomes 0. Then we have 1 by 4, 2 square 4, root 3 square 3. Okay. That is equal to 1 plus 4 and 4 cancelled. 1 by 3, which is 3 in the denominator. 3 plus 1. 3 plus 1, 4 divided by 3. So, this is a value of the given expression. Okay, 4 divided by 3. That's all for today. In today's class, we have practiced many questions from exercise 21E. There are a few more questions left which you can practice on your own. I'll be back in the next session with a new chapter. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.